Part 3 of Lesson 1 of Chapter 5 is more on trigonometric identities. We're going to be using them to complete what I call trig proof problems. So first of all, we have something called the Pythagorean identities. There are 3 of them, 3 different ones. We're going to take the first one, sine squared plus cosine squared equals 1. We're going to rewrite it. You're going to add these to your note card. So not only do I want you to have sine squared plus cosine squared equals 1, but I'd also like you to have sine squared equals 1 minus cosine squared. I'd also like you to have cosine squared equals 1 minus sine squared. All 3 of these essentially are the same identity, just written in different ways. Our next one is tangent squared plus 1 equals secant squared. I'd like you to rewrite that as tangent squared equals secant squared minus 1. And I'd also like you to rewrite it as 1 equals secant squared minus tangent squared. Again, those are essentially the same identity, just written in different ways. The third one is cotangent squared plus 1 equals cosecant squared. I'd like you to write that one down as well as writing cotangent squared equals cosecant squared minus 1. And I'd also like you to write 1 equals cosecant squared minus cotangent squared. So there are 9 different Pythagorean identities. However, really there's just 3 different ones, but we're writing them in 9 different ways. So get those copied onto your note card. Then we're going to be using those along with these cofunction identities. The cofunction identities have half pi's minus thetas in them. So there's one for sine, one for cosine, one for tangent, cotangent, secant, and cosecant. And then also the odd-even identities, which we talked about in the previous video. So we're going to use that along with these guidelines for solving trig proof problems. So please write this down on your note card as well. The first thing we're always going to try to do is we're going to try to use a Pythagorean identity. Now sometimes we'll be able to do that right away. Sometimes maybe later in the problem. Sometimes we'll never be able to use one. So that's why I indicated to do this when possible. Number 2, try to change everything into sines and cosines. So for instance, if you have a tangent in your problem, you're going to change that into a sine divided by cosine using a quotient identity. Number 3, get common denominators and combine like terms. You'll do this when you've got fractions. And then number 4, factor whenever possible. So get those 4 guidelines written down on your note card. Now we're going to use those to do trig proof problems. Here's the first one. It says to simplify the expression secant of x minus tangent of x times sine of x. Well, we can't use the first guideline because we don't have any squares. Some people mistakenly think that because sine squared plus cosine squared equals 1, they think that that also means that sine plus cosine equals 1, but that is not true. Okay? So keeping that in mind, what we're going to do here is we're going to take that secant of x function, we're going to change it into 1 over cosine of x. I'm using strategy number 2 right now and changing everything into sines and cosines. We're going to change the tangent into sine of x over cosine of x. And then we'll just leave that sine of x there. Now you can see we've got this rewritten in terms of sines and cosines. We've got 2 fractions right now. And the first fraction is just 1 over cosine. The second fraction is sine squared over cosine. And now we can take those 2 fractions, we can put them together. And if we put them together, because they have the LCD of cosine of x, we get 1 minus sine squared of x in the numerator, which is a Pythagorean identity that we can change into cosine squared. And since we have cosine squared of x over cosine of x, we can cancel the cosine on the bottom with one of those cosines on the top, and it leaves us with just cosine of x. There is the first trig proof problem. They're going to give you an expression like this. You're going to simplify it down. Typically, it simplifies down into one trig function like this one simplifies into just the cosine of x. Here's another example that's done pretty similar. The first strategy, try to use a Pythagorean identity, doesn't work here because we don't have any trig functions squared. So we'll go on to strategy number 2 and change everything into sines and cosines. we change the cosecant into 1 over sine. We change the secant into 1 over cosine. And then the cotangent, we change that into cosine over sine. So I've changed everything into sines and cosines. Now we've got two fractions. The first one is 1 over sine of theta cosine of theta. The second fraction, I'd like to get a common denominator. So to get that common denominator of sine of theta times cosine of theta, I'd have to multiply top and bottom by cosine of theta, which would give me cosine squared. Now we can put these two fractions together, and if we do that, I like what we have in the numerator because that is a Pythagorean identity. We can change that numerator into a cosine squared. Still have the LCD of sine of theta times cosine of theta. Now we can cancel this cosine of theta with one of those. It leaves us with cosine of theta over sine of theta, which we will then change into cotangent of theta. So again, the expression that they give us simplifies down into one trig function. Next example. You can see this one. We've got a different expression. Hopefully what jumps out at you is this right here. Now that's a cofunction identity. So we're going to have to change that cofunction identity into a cosine. So if I rewrite this problem, we got sine squared times cosine minus cosine of x, because we can change that sine of pi over 2 minus x into just cosine of x. Now I'm going to use strategy number 4, and I can factor a cosine of x out of this expression, leaving us with sine squared minus 1. And then that sine squared minus 1 is equal to, actually it's negative cosine squared of x. That's a Pythagorean identity as well. And so if you take cosine times negative cosine squared, you'd get negative cosine cubed. And there's your simplified answer. Next one is very similar. You can see that hopefully this jumps out at you. We have to use a cofunction identity for that cosecant of half pi minus x to a secant of x. The negative sign does need to stay out in front. And now you can see I've got an expression that I can factor out a negative secant of x from those two terms. It leaves me with a 1 plus tangent squared of x. And I like the way that looks because the 1 plus tangent squared of x is just equal to secant squared of x. That's a Pythagorean identity. And so then if we multiply these, that gives us negative secant cubed of x. The last two examples I want to go over are a little bit harder because they're fractions, and a lot of people struggle with fractions. Typically, when you have two fractions, you want to try to put them together by getting an LCD. So hopefully you can tell that the LCD for these two fractions is going to be cosine of x times 1 minus sine of x. Well, in order to get that LCD, I had to multiply the first fraction by cosine. So if I multiply the numerator by the same thing, I get sine of x times cosine squared of x. And the second fraction, I had to multiply the bottom by 1 minus sine of x. I have to do the same thing to the top. And now I like what I'm seeing in that second fraction in the numerator because those are conjugates. Now, conjugates, if you think back to first semester, like x minus 2 times x plus 2, those are conjugate binomials. What happens when you FOIL out conjugates? The middle two terms always cancel. You can see that here on this example on the right in green, the middle two terms cancel. So if I take that same approach, I now have my LCD of cosine of x times 1, that's a minus, sine of x. And the numerator is sine of x times cosine squared of x minus, this becomes 1 minus sine squared of x. Now I put brackets around all that because hopefully you can see that that is a Pythagorean identity. And that right there is equal to cosine squared. So my numerator is sine of x times cosine squared minus cosine squared, all divided by our LCD. And now I can factor a cosine squared out of that numerator, leaving me with a sine of x minus 1. The bottom I still have the cosine of x times 1 minus sine of x. And so now I can cancel this cosine of x with one of these. And the other thing I'm going to do, this is a little bit tricky. Let me come up here because I'm running out of space. I'm going to factor a negative sign out of that numerator. So this is going to become negative cosine of x times negative sine of x plus 1. Now the reason why I did that, I took that negative sign out because now, if you look, I can cancel this 1 minus sine of x with the negative sine of x plus 1. That's the same thing. So my simplified answer is just negative cosine of x. Last example, same kind of problem. We've got two fractions. What you want to do is you want to try to put those two fractions together by getting the LCD. The LCD in this problem is going to be cosine of x times 1 plus sine of x. And so to get that LCD, I multiplied the bottom of the first fraction by cosine. We do the same thing to the top of the first fraction. We get cosine squared. And the second fraction is going to become 1 plus sine of x times 1 plus sine of x. And so now we can put these two fractions together. And that's going to give me cosine squared of x. Now, I have to FOIL, where's my highlighter? Here's my highlighter. I have to FOIL this out. So if I FOIL that out, I'm going to get 1 plus 2 sine of x plus sine squared of x. And now I'm going to do a little rearranging in the numerator. If I rewrite this as sine squared plus cosine squared plus 1 plus 2 sine of x, all divided by cosine of x times 1 plus sine of x. I can now take this and change that into 1. If I change that into 1, because that's a Pythagorean identity, I get 1 plus 1, or 2 plus 2 sine of x, all divided by my LCD. And now I can take that numerator, factor a 2 out, it leaves me with a 1 plus sine of x, and now I can do some canceling. Hopefully you can see that you can cancel the 1 plus sine of x. And so it leaves me with 2 over cosine, and 2 over cosine simplifies into 2 secant of x.